Okay, I guess we already it's 5 and it might take a while, so I should start. So welcome everybody. Today I'm going to talk about asynchronous code execution under the hood. Actually, I'm going to try to mimic JavaScript, like how JavaScript runs our code in browser, and I'll try to show you how we are doing asynchronous tasks while we are doing some stuff in the background. So let's start. So there is a big question: is JavaScript asynchronous or synchronous? So for people who are not very familiar to JavaScript, this might be like they might know the answer of this question in a wrong way. People might say that it's asynchronous, but actually it's not asynchronous. It's a synchronous language. We just have one thread. We can do just one thing at one line at one time. So we cannot do two stuff at one time. So if we cannot do two things at one time, how do we fetch some data, and meanwhile how do we run some functions, render some stuff, and do other things? It's actually happening with help of the browser or the environment that you're using. It doesn't needs to be browser. You can also run your JavaScript file on Node environment. But now in this presentation, browser will be our guide to run asynchronous tasks actually. So what if we just had option to run synchronous functions, synchronous requests? In that case, since we just have one thread, it would block the UI and we couldn't see any response from the web app that we have implemented, and it would create a very bad experience. So as far as I searched, there are some valid cases for sending synchronous requests. Uh, for these valid cases are like very related to web workers and other stuff, but they are very specific, and I never had such case to implement a synchronous request. You can actually send a synchronous request using the false parameter. If you pass this parameter as false as a third parameter, then we will send a synchronous request, but there is no meaning to do that, and I will show you why. So I was planning to actually debug it on this link, but I'm not going to do it. I will do it with my own code snippets. So I have this uh, page that I implemented. It just has 6 code snippets. I will run these code snippets one by one.
Can you zoom in a little bit?
Sorry?
Can you zoom in a
Oh,
little
yeah,
bit?
you're right. Sorry.
Or a lot.
Oh, is good?
One more. Yes.
Okay, perfect. So these are my code snippets.
More.
Is it good?
You could probably remove the mobile view so it looks better.
Yeah, you're right. No.
You can there you go. That's it.
Okay, it's better, I guess.
Yeah. Thank you, Urak.
No problem. Thank you, Fritz. So these are my snippets. These are the snippets that I will these are the snippets that I will run today, and I will show how we run this today. So I want to show you how synchronous requests are blocking our UI. But before, I want to run a performance test on a normal snippet, which is like this snippet is. Let's stop it for a while. I need to explain it before. So this snippet is just like have 2 functions in it. It fetches some data from a URL. This is a API on my local. It just waits for 200 milliseconds and returns Burak as response. It's nothing fancy. It just fetches some data and it does something with those data. So this is a very common way to do stuff, common way to fetch things. So let's start a performance recording, and then I will start. Click on run. I got my response. I can stop this performance recording. So let's see. Okay. So
Sorry, any chance you can zoom in there as well?
what can you say?
Can you zoom in on the DevTools as well, please?
Oh, okay. Yeah, you're right. Did better?
More.
More? but I cannot
Voice always
do more.
better.
It's possible. It's maximum amount. Maybe I can do this. Let's take this guy. Bit here.
Yes, it's fine. This is fine. Come on.
Okay. So we are not going to stay in this performance step. You might not be familiar with this step, so it's not important. So the thing that we want to see is lots of lines which are very thin, and these lines will be like these lines representing some tasks that we did while we were recording a performance recording. So these are basically some tasks that we were in. We did some re-rendering, we did some, I don't know, some other stuff. And here is the thing, here is the request that we sent. Most probably, let me see, this function, it's come from index.html 132. We just sent a request and it takes so little time, so we didn't block anything. We could have seen this like hover states, everything works fine, there's no problem. But let's see how it works with the synchronous request one. This is the second code snippet. It's actually not fetching some data. It's just some kind of an example, but it will be very similar to that. It will just sleep for 2 seconds and then it will return back. Oops, sorry. There's someone. Oh fuck. There's someone in my. Just got my Amazon delivery. Sorry for that. Okay, can I continue?
Please.
Okay, so I showed how the ideal world would look like, and now I will show you this synchronous thread blocking function. Let's run a record. Let's start a test recording. You can even see that this power state is blocked. Now let's stop it and see what it will bring us. Okay, now you can see that there is a huge block in the thread. We just worked for this function for 2005 milliseconds, and this thin lines couldn't do their jobs, so we blocked the thread. It's not a good way to implement stuff, I guess. So yeah, that's why sending asynchronous requests are important. Let's continue. Okay, this is actually like, this is the same thing that I was talking about. You can, if you are going to check this slide afterwards, you can check this page again. So, okay, as I said before, I'm going to run the snippets one by one. I will run each line and I will show you what happens in each line. But we need some rules before doing that. First rule, JavaScript is a single-threaded language. We can do just one thing at one time. Second rule, try to keep call stack clear as much as possible. Call stack is prior. We need to finish our tasks inside of call stack before. Otherwise, this is the rule. There's no otherwise. We need to keep call stack as clear as possible. Third one, call stack is prior than both callback queue and microtest queue. These queues are queues which we send some stuff tasks to do after we finish some asynchronous tasks. I will come to that in a moment. So let's continue. This is the last slide before running those snippets. I just want to give one heads up before starting it. So we have our global execution context. This is the global execution context, but we also have some functional execution contexts. This inside of this curly brackets, we are inside of functional execution context, and until we finish this execution context, we cannot escape from it. You cannot skip it. We need to finish it, and then we need to return global execution context. This might sound a bit weird, but it will make sense with my snippet, so don't worry. Okay, this is my first code snippet. It is a pretty straight one. It's very easy. I just add this one to get ready to this page because I need to explain lots of stuff in this page. So let's start from the left top. We have a time here. It's not a realistic time. I will increase it by 1 millisecond each time I process a line, and it's just for there to keep track of time and keep track of things. I have some kind of a summary over there. I have my console, which is like the same thing with the browser console, which is the same thing with here. I have my call stack. Call stack is a stack where we put our functions, like where we put our tasks. This is last in first out stack. So whenever we push something to this stack, we need to finish the last added stuff, and then we can return the other stuffs. So that's why this synchronous function actually blocked the thread, because it came after global execution context, it got inside of the call stack, and until we finish that synchronous function, we cannot do anything, so it was blocked. This is where I will run our commands. It's not that important. This part is browser tasks. I will come to that when we are going to use some browser tasks. It's just for like XHTTP fetch and like timers. We will show the status of them. We will show what we will do after this API is fulfilled. We have our memory over there. We will save the variables that we define and the functions that we define to memory. And finally, we have our callback queue and microtask queue. These queues are very related to browser tasks. We will push something to those queues at the end of those tasks, but we will come to that in my last snippets. So let's start. Okay. Maybe we can run this snippet first so that we can see what's the result. Let's run it. The first output is hi Brock. Second is welcome. Third is welcome. Our guest task is complete. So let's run it. And in the first line, we are defining a prefix variable. We define this prefix variable into memory. Its value is high. Second line, we are defining name to the memory. Its value is Brock. Third line, we are defining print data function to our memory, and we are doing nothing about that. Some people can think that we will run this console log line next, but no, we are in the global execution context, and there's no reason for us to get inside of the print data since we didn't call the print data function. And we will just skip those two lines and directly continue in the global execution context. So our next line will be console log prefix and name. So we are calling prefix and name. Prefix value is high, name's value is Brock. So we are getting our first console output at 30 milliseconds. Now we can continue. Now we are calling print data function. When we call the print data function, we are going to start a new execution context. Since new execution context started, we are pushing this print data function to call stack. Now, since our call stack is last in first out, we need to finish working on print data first to continue working on our remaining tasks under global execution context, which is console log welcome, our guest task is complete. So now we are inside of print data. Here I created some kind of a spreadsheet for that. We have a memory of it. So we pass this data argument, and initially data argument's value is welcome. So we are adding this data variable to print data execution context memory, not to global execution context memory. And now we can start working on that. The second line is console log data. So we are giving our welcome console log at 6 milliseconds. Now we are getting to the last line of this function. So we can remove this execution context. We can remove everything that it has inside. So we won't have this welcome anymore. So it's some kind of like garbage collection, I guess. And now we also removed it from call stack so that we can return to our global execution context, and we can run our last line of code in global execution context, which is console log welcoming our guest task is complete. And we are giving this console log at 8 milliseconds, and our task is complete. This was my first code snippet. Does anyone have any questions before starting to the second one? If I will see some questions, I will answer them. Otherwise, I will continue with the second one. Second code snippet. So this was the snippet that was blocking the thread, actually. Let's see, we are defining a function, we are defining another function, we are defining a variable and assigning a value of a function to that. Then we are running a function and console log. It looks pretty easy. Let's start. So we are defining print data function to memory. We are not getting inside of this line because we are in global execution context. We are continuing. Now we define eval fetch and wait function to memory. This function just gets the data, but blocks the thread until the data returns. It's basically this. Since we are not inside of this execution context, we can continue with this line, and we are going to fetch data. So fetch data, we are defining it under memory. Initially, its value will be undefined because we didn't define anything. And the value of this thing will be equal to eval fetch and wait functions result. So now we will start the execution context of this function, and we will push this function to call stack. We need to work on eval fetch and wait function first. And once we finish it, we can return to global. But since it will take some time, since it will take 2,000 milliseconds, as you can see in here, say 2,000, we need to wait from 30 milliseconds. We need to wait until 2,003 milliseconds, and we are blocking the thread. But finally, we got our data. We have Burak as in fetch data. Now we can continue working on our global execution context since it's finished. Now we can call the go ahead. Maybe, can
Sorry.
you wait for 1 second? Maybe
Okay,
if
sure.
I finish this one, you can ask this question. I don't want to cut it. So sorry. So we are calling print data function, and when we call print data function, we will create new execution context. We will push it to the call stack. The data will be assigned to Burak as the argument is equal to fetch data. Fetch data is Burak in the memory. So we will run this. We will run console log. We will give first console log at 2006 milliseconds to console. And with the closing bracket, we can remove it. We will return to global execution context, and we will run our last line of code, which is coming at 2008 milliseconds, and we are done with this snippet. Yeah, go ahead, Jose.
Sorry, could you show me the eval fetch and wait function again?
Yeah, sure.
Okay. No, it makes more sense now. Okay, thank you.
Yeah, sorry. Yeah, okay. Yeah, the sleep function is another function we are getting from the browser API. Actually, this is a function that I got from Stack Overflow. It's just like I don't even know what does it do. It just waits for 2,000 seconds.
It's a sleep function. Yeah.
So this sleep function is not achieved with a set timeout. It's achieved with a while loop that actually blocks the execution rate.
Definitely.
Because that was confusing. Because usually when you sleep, it's a set timeout, and I was surprised that would be the result. Because I was going to ask, this would be basically when you use the synchronous XML HTTP request, right? This is what you're trying to demonstrate here.
Definitely, like it might like when you send an XHTTP request, the result might be different because we will use browser tasks for that, and I will come to that point. I used like set timeout and like fetch functions to trigger some browser actions, but this wasn't that important in this snippet since I'm going to cover them in future. But it's a great question. It would be slightly different if we used set timeout or other things, because it would be pushed to browser tasks, and then it would push to some queues, and then it would be pushed to call stack. I just skipped those for this second snippet, but I will give details about them in the upcoming snippets. Okay, I guess there are no more questions. So let's continue with the third code snippet. So, okay, here things are getting exciting. Right now we have a printl function, we have a set timeout callout, we have a console log callout. So set timeout is a browser API basically, and it will just it's very clear actually. It will just like wait for 1,000 milliseconds, and then it will do something when the time is finished. So let's run this code actually and see what this will bring us. Let's run it. It will show first console output first, and then after 1,000 milliseconds, it will show hello. Okay, let's execute this line by line. So I defined printl function to memory. I'm not getting inside of the function. I'm calling the set timeout. Set timeout function is not a function that I defined. It's inside of the browser, just like the fetch function. It's browser API. and it directly triggers something on the browser tasks. It triggers the timer in browser tasks. It has rejected status, like unchecked status, and it has print hello. It knows what to do on complete. And it will start to count 1000 milliseconds. So the difference between it will fetch and wait function, difference between this function and this function. So in here, we are actually sleeping for 2000 milliseconds, but in here, we are counting for 1000 milliseconds, but we are not counting this in JavaScript. So we are not using our thread. We are not blocking anything. Browser will handle the rest of it. If we did block the thread, then we wouldn't see this hover state until we get the hello. So this is the difference with using the browser API. So let's continue working on this snippet. So we started set timeout. Timer is started. It's unchecked. It will do something when it's finished. But right now we have our global in call stack, so we can continue working on the global execution context. We don't need to wait for 1000 milliseconds. We are running first console output. We are getting this result in the second millisecond, and still our timer is unchecked because it needs to wait until 1000 milliseconds. In the next slide, it will be in the 1001 millisecond, and it will be checked. Actually, it's in the 1002 millisecond, but it should be 1001 milliseconds. Sorry for that. Not important. Now we have our timer counted for 1000 milliseconds, and it's checked now. Now we can work this. We can run this print hello function. But before doing that, we are actually moving this print hello function to callback queue, and this callback queue it should wait its turn to get inside of the call stack, and it needs to wait until something, like there's nothing inside of the call stack. So since we don't have anything inside of the call stack, we can move print hello function to call stack, and we will create the print hello functions execution context initially, and we will run the console log hello, and we will give our latest console output at 1004 milliseconds, and we will remove it from call stack too. Yeah, this is the fourth snippet. Third snippet. Let's see. Yeah, Jose, go ahead.
Just a quick question. So after the timer is out, the print hello gets pushed to callback queue, right?
Yeah.
So, but when does the callback queue, the task on the callback queue gets pushed to the call stack?
Yeah, this is a good question. So at first I said that we need 3 rules. One of those rules is call stack is higher than the callback queue and the microtask queue. So you can push stuff to call stack if your call stack is empty. Since we didn't have anything to do in the global execution context, since we finished working on this at second millisecond, our call stack was empty. And since our call stack was empty, we were able to push it to call stack actually. And that's how we run it. But this is a very easy example. In the next snippets, it will get much more harder and trickier because we will have multiple stuff, both in the call stack and the queues.
Okay, thank you.
No problem. So, okay, let's continue the fourth code snippet. So when I check this snippet in a naive mode, I see that we define the print hello function. We run this set timeout. It's a bit weird because we will just wait for 0 milliseconds, and then we will run print hello. If I think in a very simple way, I would say that, okay, we will run print hello initially, and we will get the result of this console log hello initially. But actually, it won't be the case because call stack is prior. Let's run this code snippet first to make sure that we are showing the first console output first, and then we are showing console log hello second. Although it waited just for 0 milliseconds, basically it didn't wait. Let's see how that happened. How did it happen? So we defined print hello function to memory. we are not getting inside. We are directly going to set timeout function. We are calling set timeout. Set timeout triggers the timer feature of the browser tasks. Initially, status will be checked because we will wait for 0 milliseconds, which doesn't mean anything. So we are initially ready to push printhello function to queue, and we will push printhello function to the queue. Now we have a conflict, actually. We have a thing to do in call stack. We have a thing to do in callback queue. Which will go first? Since the rule says that call stack is prior, we cannot move anything from callback queue to call stack. We need to finish global execution context first. So we need to give first console output first, and then we will remove global execution context from the call stack. Now call stack is empty. We can move printhello function inside of the call stack, and we can start the execution context of it. And we will run the execution context. It will give the console log hello at the 5th millisecond. And this is how this snippet works. This is why we are getting hello after first console output, just like here. So call stack is always the first guy goes inside. So my 5th code snippet. Let's check it. We have a JSON file response function. We have a print data function. We are defining a fetch data variable, which is fetching some data, which is using a browser API and going to some URL and getting some data. Afterwards, we are using fetch data.then. We are using some methods, and we are running. We are just passing some functions to fetch data promise, and we are running the last console output. Let's see how it will look like before running the snippet. So we are getting first console output first, and we are getting Burak result afterwards. It makes sense because we are fetching some data. It cannot resolve immediately. Like we will render this first console output, and then we will show the data in any case, even if this one resolves in 0 milliseconds. So let's start running it. I defined JSON file response to memory. I defined print data to memory. I defined fetch data variable to memory. But there is one different thing about fetch function from the browser. So fetch does two things. In the JavaScript side, it assigns, it creates a promise, and this promise will be assigned to fetch data variable over there. And it does this in the front JavaScript side, and it does something different in the browser side. It triggers XHR feature of browser, and it starts to fetch some data in the background. Let's see what this promise looks like. It's actually like when I was a junior front-end engineer, it was so hard for me to I didn't even want to hear word of promise because it was a complicated thing, but it's not actually complicated. I simplified all of those. So we have our status field, it's pending initially. We have our value. Value will be the value that we will get at the end of our fetch request. We have our own fulfillment array, which is empty. We don't know what to do. And we have some other stuff inside of this promise object, but they're not important. So we can avoid them for now. So in the second millisecond, we started fetching some data. We created our promise. Everything goes good. We are still in the global execution context, so we can continue working on that. And we are running fetch data.then JSON file response. So this then method is a very badly named method, if you ask me, because it feels like it's going to actually run this JSON file response function. But it actually, the only thing that it does is it gets this parameter, this function, and it just pushes it to the onFulfillment array. It's just like onFulfillment array dot join dot push JSON file response. It's just that. And then we are pushing print data function also to the fetch data promises onFulfillment array. Now we have two things to do when our request resolves, and we can continue working on our global execution context since there's nothing more to do. Now we are giving our first console output. We are removing global execution context, and we are still fetching our data. This request will resolve in 200 milliseconds. It's a localhost request. It's just like sleeps for 200 milliseconds and returns Rock, I implemented it to be consistent with the snippets over there and over here. So it will wait for 200 milliseconds. Let's see when we started fetching some data. We started at 2 millisecond. It should be checked at 202 milliseconds. Now we don't have anything in call stack. We are our request fulfilled. It's checkmarked. Now we can push JSON file response and print data functions to microtask queue. And we also updated the status of the promise to fulfilled and the value to Brock. Now we can, now since we don't have anything inside of call stack, we can move stuff from microtask queue to call stack. We are moving JSON file response. We are running this response.json inside of this execution context. We are getting this object outside, and we are after the closing bracket, we are removing this function from call stack, and we are pushing print data inside of the call stack, and we are running print data function. It's just going to get the data.name. It's just going to get the data, and then it will console log the data.name, and we will give our last console output at 207 milliseconds, and this will be the end of this snippet. So, okay, that's called snippet. This is the 6th snippet. This includes everything. This will have lots of conflicts. We will have to decide what to do. Let's see what it will do actually. So let's check the code. It's defining a print data function. I skipped this response.json and other stuff because eventually it will return an object. So I skipped all of those. Like print data will just render console log run console log Brock command. We have this printLO function. We have this block for 2 seconds function. It will just sleep for 2,000 milliseconds. It will do something for 2,000 milliseconds, and it will return a result. We have our set timeout. We have our fetch. We have everything in this snippet. So let's start running it. Okay, we have our print data function. I defined it on the memory. I'm not getting inside of it. I'm continuing printLO. I defined it on the memory. I'm defining also block for 2 seconds on the memory too, and we can continue working on global execution context. So with that line, we are running our first browser task. We are calling set timeout for 0 milliseconds, and we want to run printLO after 0 milliseconds resolves. So since 0 milliseconds is nothing, it resolves immediately. Timer feature resolves immediately. We are pushing our printLO function immediately to callback queue. But still, we have a global execution context inside of our call stack. We cannot take this guy inside of it. It was ready in the 3rd millisecond, but it needs to wait. We are continuing executing global execution context. We are defining this fetch data variable to memory. It's initially a promise. And also fetch starts an XHR request on the browser tasks section, and it starts to fetch some data from this URL. So still, printLO cannot get inside because we have stuff to do in global execution context, so we need to continue. We are pushing print data function inside to the fetch data promise. Now we have a thing to do after XHR request resolves. We know what to do. But still, we need to wait for the result. Now, we are calling the block for 3 seconds request. This will start an execution context, and we will immediately push this block for 3 seconds to call stack. And since this is last in first out, we need to resolve this function first to continue working on global execution context. And now we will just wait for 2,000 milliseconds. In the meantime, while we are waiting for 2,000 milliseconds, our request to localhost 2000 URL, it's resolved now. Now we can push print data function to microtask queue, and it can also start waiting. But we are still inside of this block for 3 seconds function. We still have nearly 2,800 milliseconds to wait. So we just need to wait. We can't do anything. In 3006 milliseconds, now that finally it is finished, we can remove it from call stack, we can remove the execution context, we can remove everything from it, and we can continue working on the global execution context. Now, as you can see, I have stopped doing callback queue, I have stopped doing microtask queue, but it's not important. Always call stack queue is prior, so you cannot push anything until you finish it. We are running our last line in the global execution context. We will give our first console output at 3007 milliseconds. Now we can remove global execution context from call stack since we don't have anything to do. And now, okay, it was a bit spoiler, sorry for that. So we have two things to do. First, we have a printLF function inside of callback queue, and second, we have print data function inside of the microtask queue. Which goes first? There is a rule for that too. This is a rule defined by browsers, and it's same for all browsers. Microtask queue is prior than callback queue, so we will push print data to call stack, and we will start running print data function, and it will give output of console.brag at 2009 milliseconds. And this poor printLF function, which started waiting at first millisecond, it still needs to wait. It's time for this guy to get inside and work. And we will remove print data. We will move printLF function to call stack. We will run printLF function, and we will get our last console output at 3012 milliseconds. And this is the end of this snippet. So yeah, this is the ending slide, but I'm going to show you one last thing. Maybe, I don't know if I should show it because it's over time already. I don't know.
Go ahead. If we're still here, we're interested, definitely.
Okay. So anyone have any questions about those snippets? If no, okay, yeah.
I do. Sorry. Can you show me the previous snippet, please?
Yeah, I can show you from here if you want. Maybe you can also run this guy, and you can see the result of it. So we are waiting for 2000 milliseconds. We are running Brock and hello, and this is the fifth snippet, Jose.
No, this is the 5. I don't see the 5. So you have so you have fetch data. You write then. Okay, so you write the. So you pass the parameter of then is always only the function name.
It's just taking this past parameter, and it just assigns this parameter to the unfulfillment array. This is just what it does. Let's go back to this snippet actually. Okay, the only thing that this fetch data.then does is takes a function and push that function to unfulfillment array of the promise. And this is coming from the promise actually. This is a method of promise.
Yeah. No, I'm just asking about what's formally the function argument of the then function. So you're passing the function pointer, I guess, function reference.
Yeah.
But I guess it's just about the argument. So how does the function pass the although the promise passes its response as an argument to just JSONify response, for example, you know?
Yeah, I got your question. You're asking how this JSONify response function getting this response argument. I cannot say that I know it 100%, but I have a guess. It's a very good question. It's a mystery that I need to solve actually. Most probably, like browser is handling that whenever this XHR request resolves, it will get the value from promise, and it will just push it to the next function that this promise needs to do after fulfilling.
Okay, and then it's the same. Then we'll pass its response to print data, right?
Mm-hmm. Yeah, definitely. Most probably it's like that, but as I said before, I cannot give you one clear.
Okay, cool. Thank you.
No problem. It's a great question. I will search. So, yeah, Andre.
One more question follow up on just this. Like for the second, which would be the argument for the second method?
Can you repeat it?
Which would be the arguments for the second method from then?
The argument for the second method is the result of the first method, first function actually.
Cool. So it's a sort of chain. Yeah. Thanks.
Yeah, it's sort of chaining. So my last thing that I will show, it's not, so I said that I will show how we are running asynchronous stuff in browser. I showed this just with promises. I didn't show anything from async await, which is much better than promises if you ask me. But the main goal of this presentation is to just show how things work under the hood. But I want to show how iterators work in JavaScript, so that I can cover up one of my lies when I was showing you some, when I was trying to run some lines. So let's implement, oh, I need to zoom in, I guess, right? How can I do this? Oops, can do it. Is it readable for you guys?
Yeah.
Okay, perfect. So I will create a custom iterator function. This custom iterator function will get an array as an argument, and we will keep an index inside of it, which will be 0 initially. And then we will define a function inside of this function, which name is next, which will basically iterate over the array that's given to this custom iterator function. So it will calculate the current element, and we will calculate it like this: array 0th index of array, not 0, sorry, index. And then we will increase the index, basically, and we will return current element. So this next function will basically return the next element from the iterator, like the past array. And now we will return this next function inside of an object. So our custom iterator is ready. Let's use this guy. Let's define an array iterator, which is equals to custom iterator. Let's pass an array 4, 6, and let's use this iterator. Okay, and then let's say that we are doing some stuff in here. Okay, so this is an iterator. It's just like a basic iterator. I guess everyone knows that you don't need to be a JavaScript developer to do it. It's a global thing, so it's not just for JavaScript. Maybe if I can zoom out a bit. So let's see if this works, if I get any errors or not. Okay, I'm not getting any errors. So this is like the starting point to understand how async await works in under the hood. But it's a whole different topic, and I'm planning to do a second lightning talk, to also show how async await works under the hood. But I cannot do it in one session, both promises and async await. But I want to show a small bit of it before. So we have a custom iterator. With this custom iterator is have an index, it have a next function, and it returns this next function. And I define this array iterator variable. It's equal to custom iterator function. As we can see, custom iterator is returning this object. This object includes this next function. So this array iterator.next, when we run this array iterator.next, we will basically iterate over this array. And in the meanwhile, we don't need to iterate all of those items. We can do some other stuff in the meanwhile. We don't have to finish it in one go. So let's run it just like this, this page that I showed you. I don't have a page for it, but I think we can you can track it by now. So I defined a function. I'm not getting inside of a function. I defined an array iterator. I defined it to memory. it's equal to this object, we need to get inside of this custom iterator functions execution context because we are calling it. So we are inside of this function. We are defining an index inside to memory of this function. And then we are defining a function, which is called next, and we are returning it basically. So this execution context is over. And since this execution context is over, as I showed you before, this index will be gone. We won't have any array, and everything inside of this execution context will be gone, and we cannot reach it anymore. But somehow we are able to do that, because when I click on when I run array iterator.next, it is running this. It is defining this variable. It is getting array, and it's calculating the first value of this array. How this happens? Because like this array is already gone, this index is already gone. This is what closure is in JavaScript. So whenever you define a function inside of a function, this function that you defined, this next function, will create some kind of a backpack, and we will add all of the variables that you defined in the enclosing scope. It will get all of the variables that defined in the enclosing scope to its backpack. So although we don't have this array and index defined inside of this next function, we can still iterate over it. And we are continuing iterating over that. We are running iterator.next, we are getting 2. Our index is increased to 1. Now in the next iteration, we will get the first, second element of the array. And in the meanwhile, we can run some tasks. We will get array.iterator.next. With the array.iterator.next, we will get the second item of the array. We will run another tasks, and at the end, we can get the final item of this array, and it will be over. So that's how iterator works in JavaScript. And I wanted to show you this example because as I showed you in this snippets, I said that print data function is being called. We are creating an execution context. We are defining some stuff inside of it, and we are removing everything. With that information, you cannot run iterators. You cannot run this iterator in JavaScript. And I wanted to show you this example so that I don't want to give any missing information. This is the help of closures to do those stuff. I hope it's clear. And this is the end of my slides. If you have any questions, I can take them. I have some references over there. This first reference is super good reference. I learned like most of the stuff from this guy. This guy is super good. He is very into under the hood of JavaScript. So I will highly recommend you to watch it if you're interested on those under the hood stuff. And the second reference is pretty boring.